Alright, so good afternoon, class. So today we're going to start our lecture for the week 2 for Building Technology 2 subject. So as promised, this week we'll start our drafting activity. Okay, so you're going to make a start making the the plans for a two-story residential building, which is made of both concrete and wood. So I hope that you'll be able to learn how to develop the building plans. Okay, so for our midterms, I'll give you a sample of which you're going to copy, and then for the finals, you're going to develop your own design and uh, working drawings. Okay, but before that, I think it's also paramount that I also teach you the different parts of a building so that understand what you are drawing also. Okay. So the major parts of the building, one, you have what you call the superstructure. So it is the portion of the building above the ground. So if this is the ground, okay, this is what you call here the superstructure. As you can see that that shaded part. This is the below the ground. Okay. Then we have the substructure, the habitable portion of the building found below the ground. Okay. So if this is the superstructure, this is the substructure here. So example of that would be okay. There are some malls, for example, when you look you when you go down, you can see some more shops. Okay, it's below the ground level already, so it's habitable, but um, it is below the ground. When you say it's a superstructure, it is above the ground. Okay. Then we have what you call the foundation. So it is here. This is the structural portion of the building that transfer the building load into the soil. So when you say building load plus, that's the total weight of the building. The weight of the concrete used, the weight of the steel reinforcement used, the weight of the moving the people, the moving loads within the building, also including the machineries and other stuff. It's going to be transmitted to the ground. That's why when you reach your um, higher level mathematics in architecture, you're going to have a steel and concrete design subject where you're going to compute the size of the foundation and the number of reinforcements needed. Okay. Now there are three types of substructures. Okay. The one is what you call the slab on fill. A slab which rests on the ground and not suspended. Then you have a crawl space, which is in a building without a basement, an unfinished, accessible space below the first floor, which is usually less than a full story height. I think this is prevalent class, especially in the old designs of buildings here in the Philippines, when you can find a crawl space underneath the house. Okay, and what you call the basement, which is the lower story of a building, either partly or entirely below grade. Now, what you're going to watch out class if you're going to design a basement is you have to make sure it is waterproof well. Otherwise, there's a tendency for water to come in. Okay? So if you look at if you're going to use CHB, okay, so this CHB is used commonly here in the Philippines. It is not a good practice that you just um, finish one portion of the CHB wall facing the ground. Okay? You know why? Because the unfinished portion of the CHB, which faces which is the one which is exposed to the elements, to the soil outside, there's a tendency for water to creep through it. So that's why, class, um, it is best that if when you construct something with a CHB, that you make um, a hole big enough so that you can send a worker to do the finishing on the other side also. So you have to finish both sides of the CHB. You have to waterproof both sides to be sure. Okay, let's move here. So when you say foundation bed, so the word foundation is applied to um, construction below grade, such as footing courses, basement walls, forming the lower section of a structure. Okay, so it is the natural material, the particular part of the Earth's surface on which the construction rests. So that's what is your foundation bed is all about. And it's also the special construction such as piling or piers used to transmit the loads of the building to firm the substrata. So what does this mean? So I think you have observed already, class, in the construction of big buildings which are near areas that are quite swampy or wet, that what they do first is they drive a pile. Okay? So they drive a pile up to the layer which is already hard. That is to prevent the building from sinking. Okay? So they pile drive first before you're going to place the footing. Okay? So you could also use piers, especially if you're just constructing residential building or buildings with of scale which are not so big. Okay, so you're going to uh, pile some wood, okay, closely together so that the soil will compact and it becomes stronger. So that's what it means, the transmit levels of building to firm the substrata. Okay, but there's a computation for this class. I think it will be introduced once you reach, like what I've said, your fourth year or fifth year in architecture. Okay, I think we already discussed the foundation bed, which is the natural material on which the construction rests. Then you have what you call the foundation walls, which is the part of the building foundation which forms the permanent retaining wall of the structure below grade. Then we have foundation piers or columns. Piers or columns below grade to distinguish them from similar construction above grade. And you have what you call a grade beam. This is the part of a foundation system which supports the exterior wall of the substructure and bears directly on the column footing. Then we have what you call the footing courses, the lower portions of walls, piers or columns which are spread to provide a safe base. So these are the types of foundation beds. First, we have the rock solid bedrock or ledge. So undisturbed rock masses forming an undisturbed uh, part of the original rock formation. So some examples of harder rocks and granite, slate, sandstone, and limestone which are capable of carrying the load of any ordinary structure. So examples of softer rocks are shaly slates, and certain marly limestone and claystones. You also have what you call the decayed rock or rotten rock, which are sand, clays, and other materials resulting from the disintegration of rock masses, lacking the coherent qualities but occupying the space formerly occupied by the original rock. Then what you have what you call loose rock, which are rock masses detached from the ledge of which they originally formed a part. Then we have what you call the gravel, which is the detached rock particles, generally water worn, rounded, and intermediate in size between and particles and boulders. Then you have what you call the boulders, which are detached rock masses larger than gravel, generally rounded and worn as a result of having been transported by water a considerable distance from the ledges of which they originally formed a part of. And what are the allowable loads on foundation beds? Thorough investigation is required before one can determine the allowable unit load on the foundation bed. So when material and conditions are uniform over the entire site of the building, a uniform unit load may be used. In cases when entirely different conditions exist under different portions of the same building, the unit load on the foundation bed must be reduced as much as possible so as to reduce the differences in settlements between the two sections of the building to a minimum. So before you construct class, you have to collect the data first of the soil that you're going to build your building into. Okay? So you're going to perform laboratory tests and you're going to obtain a section of the soil and have it analyzed so that you can be sure on the design of your footings and foundations for your building. Okay? So the goal here is to make sure that your building will not sink. Okay? Especially if the soil looks uh, if you look at it at the first glance it's like it's swampy or wet. You have to investigate, or if it's near the ocean, you have to get the data for it. But to be safe class, it is I recommend you to always get the data before constructing something. Let's move into the next. Okay, so we'll stop at here. So site investigation. So, like what I've said, before you construct a building, before you construct something, you must investigate the site first. So, before any design is made, the architect is required to get as much valuable data about site excavation and building erection at the project site in order to determine the character of the materials which will be encountered at the level of a foundation bed. Okay, so you really have to determine class what materials are below your site. Okay, you can look at it. You have to determine it. What I mean is because some sites class they may be quite prone to liquefaction. Okay, so it would be dangerous because remember um, your liability for the project extends for more than a decade. So I think it's 15 years. So you have to make sure that when you construct something, it is located in an area where it's feasible to build it. Or if the owner really wants to build at that location, you have to make sure that the design of the foundation suits the area. Okay? So that's why you have to have site investigation. You have to determine how far the site is from the fault lines, what are the soil conditions, what are the history of the site. Okay, so you have to know if that site is flooded. You have to know if there are bodies of water near it, or if there's an underground water stream flowing below it. Okay? Because it would affect the project when you're already constructing it. Okay? Then the I think the gist of the matter here, class, is that it would already be too expensive to make amends if your building's already constructed. As much as possible, if you're still in the design phase, you must make sure that the design is suited for the site where the building will be built. Okay? So these are the methods of exploration. The one is test pits. So for shallow work, an open pit is the most suitable method since it calls for an actual inspection of the undisturbed material over a considerable area. Then you have test borings. So for excavations that are carried no deeper than the proposed level, the underlying material may be investigated by test boring. Okay, then loading tests. Loading tests of the materials forming the foundation bed are made to assist in determining its safe bearing capacity. Okay, so you have to determine class the bearing capacity of the soil, but it is something that we're going to consult with our structural engineers. Okay, but as architects, we also have subjects in structural design. So the purpose of it is that you can uh, understand also how the computations are made. Okay? But we have allied professionals who will be computing classes if you're already in the practicing already as architects. Okay? So I think I would end my lesson for week 2 here at site investigation. So I just hope class that you have a little bit understanding now about building technology. Okay, so this is a different aspect. This is the theoretical aspect of building technology. Then the application aspect would be for you to develop the construction drawings yourselves. Always remember, class, that uh, what or you are drafting, what you are drawing, it's not just drawings. It's part of the contract documents, and it is the instruction to the site on how you're going to proceed in building the structure. Okay? So if you have any further questions or clarifications, class, feel free to ask me anytime or raise it during one of our synchronous no, synchronous consultation sessions. Okay, so stay safe always and see you next meeting.